Afshania. My serial number is 101466119. Today I'm going to talk about our assignment 3 that had two different parts, part A and part B. First, I'm going to go through the part 1, and so I'm not going to really talk about the given codes, and I'm just going to talk more about the questions because we have like limited time. So yeah, these are the given codes. We just ran these codes. These are the libraries we're gonna import. This is the URL of the image we're gonna use. This is the image we implied, and we're gonna make some like differences, some effects, and just gonna go to the first question. So he asked us to create a kernel to detect 45-degree lines. So as you can see in this matrix, this sets is like for 45 degrees that I did. So the line is gonna be like going upwards to the right. It's only gonna bold those lines that has 45 degrees. As you can see in this result, we can only see the 45-degree lines are like bolded. And yeah, these are we're using a convolution layer in this case. And then we're gonna do the same, but we're gonna make a kernel that's gonna detect 135-degree lines. So 135 degrees is gonna be like downwards to the right too. So it's only gonna uh, sharpen, like bold those lines for us. As you can see, I think this is slightly better than 45 degrees. And then we're gonna try different kind of like kernels, like edge detection. So I would say this is not really like strong. As you can see, the result is not really good. That's why we're trying the different numbers, different sets. So as you can see here, we got a little bit better like image. It's like more sharper. That's why this is -4. That's why in the middle I use even a bigger number that we saw, that we can see that this picture is very bold, and we can see all the edges and the corners, but it still has some kind of like noises too. I think that's not necessary. And then we go into our part 2. We use a different data set, so we're gonna import our libraries, and we're just gonna create our model. This is our model. Yes, this includes conv2d, max pooling, flatten two different dense layers we use, and I'm gonna talk about it later. And yes, so we're just gonna train the network. These are the results. So we wanna like show it in the plot, so it's gonna be better for us to just talk about it, analyze it. So yeah, as you can see, the training accuracy is gradually getting better, but the validation accuracy has a peak and then just going steady. And the first question asks, do you see any like sign of overfitting? Oh, yes, absolutely. And it starts as early as epoch, I would say, like 7, 8. You can already see it's getting like worse. And yes, and the differences between these two lines shows like the overfitting that we have, and it's not like in a good way. So the next question is like how many layers. We have 5 layers here, and I'm just gonna talk about them like briefly as the question asked. uh, so the first one is a convolution layer. The second one is a pooling layer, and the flatten layer, and a two dense layer we have. So the convolutional layer, what it does, it just like filters out the image in the size 3 by 3 pixels, and actually we use this to like capture the edges and lines earlier in the assignment. And then I'm just gonna briefly say it because I said everything here. And then we have a pooling layer that reduce the height and width then with the image. And then we have a flatten that turns all the entire image with its value to one vector. And we have the dense layer, so the dense layer then just gonna use that data to actually find out to show what the image actually is. And the second dense layer acts like an output layer. Yeah. And then he asked us to add one or more convolution layers. So what I did, I just added one because it takes like much more time to add more. Actually, that's another reason why I used Visual Studio. So as you can see here, this is the added line, and we're just gonna go see the results. So these are the results, and you can see then comparing to the first one, we have much more overfitting, but our training accuracy is much better because we have, it's like the model is more complex. We have more like capacity of data. But as you can see, the validation accuracy just like really bad, and it's the minimum. And I would say this model is kind of like failed. So it says, yeah, describe what's the differences between them. So yeah, I already said that, and actually, like we can say not necessarily, not always, adding one more layer and make the model more complicated will always help. No, for example, as you can see here, the simpler model we had a better performance for unseen data. Uh, so yes, this is the comparison, and then we're just gonna add a dropout layer and gonna see what happens. So as you can see, I added here a 0.3, and we're gonna see the results. Um, this is the results. As you can see, yes, the training accuracy is still good, high, and the validation accuracy got a little bit better, and actually the overfitting kind of improved. And actually that's what the output layer does. It improves the overfitting. And like how does it do that? So what it does is just like drops out actually zeros in the line that is been applied to, so our machine cannot really like rely on that. So because usually in these machines it's really like common that the model is just gonna memorize the training example instead of actually learning the pattern and like how to do it. So drop out by just thinning and making shorter the layers makes the our machine like don't rely too much on the training examples, and make it more like generalized for the whole unseen data. And yeah, that was the assignment 3. Thank you so much.